Hello and welcome to the probability quiz practice, where we're really looking at tree diagrams and area models to determine probabilities. We've got some practice problems here that are similar to what you're going to see on your quiz, so I want to make sure you understand how to do these. Here we've got two spinners. We're going to spin one and then we're going to spin the next. So those are independent events because the outcome of one does not change the probability of the next. So we can do an area model for this, although it says to draw a tree diagram, so we could do that as well. So the first spinner, let's make the options for the first spinner. We could have blue, or we could have red, or we could have yellow. And the probabilities for those, if these are all equal and there are two blues, that's a 2 out of 6, which is 1/3 probability. For red, there are 3 out of 6, which is 1/2. And for yellow, it's 1 out of 6. After we spin this one, we're going to spin this one, and so there are 3 possibilities that could happen on the second spin: blue, yellow, or red. And so this is a 1/4 for blue, a 1/4 for yellow, and a 1/2 for red. 1/4 for blue, 1/4 for yellow, 1/2 for red. Same thing here. 1/4 for blue, 1/4 for yellow, 1/2 for red. Okay, there's my tree diagram. What's the probability of spinning a blue and a yellow in any order? So that could be blue and yellow, so that could be this one here. Let's find the probability of that. We multiply the 1/3 of a blue times a 1/4 of a yellow and get 1/12. It could also happen if I have yellow-blue down here. That's 1/6 times 1/4, which is 1/24. So I need to add those together. In order to add fractions together, I need a common denominator. Let's change them both to 24ths. I would need to multiply this by 2, so it's like times 2 over 2. It's 2 24ths plus 1 24th equals 3 24ths. That's my answer here. Probability of getting the same color on both. Well, that would be blue-blue, which is this, which is 1/12. Or red-red, which would be 1/2 times 1/2 is 1/4. Or yellow-yellow, which would be 1/24. So let's put that down here. That could be blue-blue, which is 1/12. Red-red, which is 1/4. Yellow-yellow is 1/24. So we need to change these all to 24ths again, so we have a common denominator. And then remember, we just change these times 2's, times 6, times 1. Now we add the tops. 2 plus 6 plus 1 is 9. Keep the bottoms the same. Oh, I can actually simplify this if I divide by 3 and divide by 3. That gives me 3/8. So there's my answer for the same color. Next problem. We've got Lemire and Rachel going to homecoming. Lemire, these are independent events and there's only 2 of them, so let's think about an area model here. It says draw an area model. Lemire thinks there's a 40% chance he's going to go. So this is his yes, and it's 40%. Let's do a little bit less than half, and his no is 60%. Right? Rachel thinks she's probably a yes. So this is her 90 yes, and 10% no. So what I need to do is multiply these probabilities. This is going to be 0.04. This is going to be 0.06. Multiply here, it's 0.36. Multiply here, it's 0.54. My question says, what's the probability that at least one of them goes? So that would be Rachel's a yes, Lemire's a yes. That would be Rachel's a yes, but Lemire's a no. At least one of them is going. Rachel's a yes, or Rachel's a no, but Lemire's a yes. That would be at least one of them going. So if I take 0.36 plus 0.54 plus 0.04, that gives me 94%. The other way I could do this is I could say, well, that's everything except for this one. So if I just subtract 6 from 100%, that gives me my 94. That's another way you could do this one. Okay, you are so bored. I don't know why this is doing this. You flip a dime, then a nickel, then a penny. List the sample space. This one just tells me to list. So let's think this through. If we have heads for the first flip, I could have heads for the second, and then the third, one of them would be heads, one would be tails. If I change the second flip to be tails, I could still have the heads and the tails. So that's 4 of them. Then the same 4 will be repeated if instead of the first coin being heads, if the second coin was tails. I could put these same things down. So 2 with heads, 2 with tails, and then heads, tails, heads, tails. There are my 8 items in the sample space. What's the probability of flipping all tails? Well, that would be this one, be 1 out of 8. 1 heads and 2 tails. That would be here, that would be here, or that would be here. That is 3 out of 8. Same number of heads as tails. That would mean 1 head, 1 tail, or 2 heads, 2 tails. That's impossible. Anything that's impossible, we would write a probability of 0. My pet rat Einstein is about to go through the maze. Find the probability he'll end up in room A, B, and C and say where to put the cheese. So my rat's going to come here and make a choice. He's got a 1/3 chance of choosing each of these options. If he chooses to go up and he comes here, now he's got a 1/2 chance of choosing these. So the probability that he lands in this area, he have to choose a 1/3 and then a 1/2. Multiply those together, that gives 1/6. The probability here that he lands in this one would also be 1/6, 1/3 times 1/2. Now this one, if he makes a 1/3 choice, then he comes here and he's got another choice, 1/3, 1/3, 1/3. So if he makes this top choice, that'd be 1/3 and 1/3, that is 1/9 that he's going to be here in B. Or a 1/3 times 1/3 is 1/9, he lands here in A. Or a 1/3, 1/3, that's 1/9, he lands here in C. We've got one more choice here, and that's 1/3, but once he makes this choice, there's no other choices, he just ends up there in A, so that is just a 1/3. Now, A, we've got this 1/3 down here, we've got this 1/6 up here, and we've got this 1/9 in the middle. And we need a common denominator for those. How about 18s? This changes to be times 6, times 3, times 2. Add those together, we get 11 out of 18. For B, he could be here 1/6 or here 1/9. So again, we could change those to 18ths, and that's 3 18ths and 2 18ths, 5 18ths. And for C, it looks like the only way he gets to C is if he ends up here at the 1/9, right there. That would be 2 18ths and 5 18ths, 6, 7, and 11. That's 18 18ths. We got them all covered. Okay, so I hope that was a helpful probability review. Check your paper, make sure that you're prepared for your quiz.